This is the Satellite Foundational course for GOES-R training on the baseline GOES-R volcanic ash product. The subject matter expert on this is Mike Pavlonis from Noah Star, assisted by Justin Sieglav at SIMS. My name is Scott Lindstrom and I'll be navigating you through this training. The goals of this training are to introduce the baseline volcanic ash products that will be available to users from the GOES-R ground system. That is, they'll be available in AWIPS. This module will also outline best practices for using the baseline GOES-R volcanic ash products and highlight differences between the baseline product and the VOLCAT, that is the Volcanic Cloud Analysis Toolkit products that some users currently access. Baseline volcanic ash cloud height and ash mass load products are computed every 15 minutes for the full disk domain. They're not produced for CONUS or mesodomains. These products are quantitative, that is, the values computed have been validated and shown to be accurate, out to a solar zenith angle of 60 degrees. That's near the boundary between yellow and green on this globe. The products are qualitative for solar zenith angles beyond 60 degrees, meaning that the values shown may not be accurate, but the general distributions are good. Product computation requires ABI bands 10, 11, 14, 15, and 16, which bands have the wavelengths noted on the slide, 7.4, 8.5, 11.2, 12.3, and 13.3 microns. Bands 10 and 11, the low-level water vapor band, and the SO2 band, are used because they sense radiation that is absorbed by sulfur dioxide, a common discharge from volcanoes. Baseline products, ash cloud height and ash mass loading, were designed to identify volcanic events if at all possible, so there is a degree of over-forecast in the fields. From a statistical point of view, there is no penalty for false alarms so long as the probability of detection is high. The best practice is to use the information from the baseline products. If these products suggest an eruption may be occurring, then verify the eruption's occurrence by looking at GOES-R's multispectral imagery, visible, near-infrared, and infrared, to determine exactly where the ash might be. In this way, you can filter out any false alarms. Users have been using VOLCAT, the Volcanic Cloud Analysis Toolkit, products and services for a variety of GEO and LEO sensors for several years now. The algorithm that produces the baseline GOES-R volcanic ash algorithm was finalized in 2010. VOLCAT is the result of many new innovations that have been developed since, after the baseline algorithm was finalized, and includes more advanced applications including volcanic thermal anomaly alerts, volcanic eruption alerts, volcanic cloud tracking, volcanic cloud characterization, both ash cloud height and mass loading, and the generation of key parameters needed to run and validate dispersion models. The baseline algorithm was finalized to allow development of the GOES-R ground system. VOLCAT now directly addresses operational needs. The next few slides were developed using imagery from Himawari 8's AHI imager that is very similar to GOES-R's ABI. This example is a volcanic cloud that originated over Zhubanovsky on Russia's Kamchatka Peninsula on February 12, 2016, and then moved into the Anchorage-Vac region of responsibility. The eruptive cloud is enclosed by a brown contour in the animation. It shows up pretty well in the RGB image. Note that this RGB image is not baseline, but it is used here to define the ash cloud. We'll use that aerial definition later in the depiction of the eruption by baseline and VOLCAT products. The RGB components are noted. The split window difference is the red component of the image. The brightness temperature difference between 11.2 and 8.5 microns is the green component, and the 11.2 micron brightness temperature is the blue component. This shows the split window difference, 11 minus 12 microns, from Himawari 8's AHI, again channels that are very similar to GOES-R's ABI, for the same example of a volcanic cloud that originated from Zhubanovsky over the Kamchatka Peninsula on February 12, 2016, and then moved into the Anchorage-Vac region of responsibility. The eruptive cloud is enclosed by a brown contour, and this product neatly defines the region that will be considered next. The cloud shows up pretty well in this non-baseline product. The GOES-R baseline ash cloud top height algorithm provides pixel height estimates for all pixels that might contain volcanic ash. Only those pixels that are confidently non-ash do not have height estimates. The ash cloud from Zupanovsky shows up nicely, again enclosed in the brown contour defined on the previous two slides. But there are plenty of pixels identified as having ash cloud height that don't. This is why you must verify the GOES-R baseline algorithms with other information from individual bands on ABI or on AHI. Similarly, baseline ash mass loading provides pixel mass loading estimates for all pixels that might contain volcanic ash. Only those pixels that are confidently non-ash do not have mass loading estimates. In the case of this product, the eruptive cloud, again enclosed by the brown contour, is a lot harder to identify. You would need to be looking at other AHI single channels or channel differences to zero in on it. This slide shows the baseline ash height product on the left and the VOLCAT product on the right. There are similar values within the ash cloud itself, but the baseline products have many false alarm pixels that a human interpreter must screen out. Note that VOLCAT will issue an alert as soon as an eruption is detected. Baseline products do not include an alerting capability. Again, the baseline GOES-R ash mass loading product is on the left, and the VOLCAT ash mass loading product is on the right. Within the ash cloud, ash mass loading products show similar results. But GOES-R baseline products have a lot of extraneous return outside the ash cloud, which is delineated by the brown in the baseline product. Baseline and VOLCAT products do have similar accuracy within the ash cloud. You can find more information about the baseline product and on other products used to detect volcanic ash at these websites. Check them out. Baseline products give information that must be used in tandem with the multispectral imagery on AHI or GOES-R to isolate the true aerial extent of the ash cloud. This is because the baseline product does not penalize for false positives. VOLCAT products that have been developed since the baseline products were inserted into the GOES-R ground system are more familiar to users who need volcanic alerts. Mike Pavlonis is a subject matter expert on this product, and his email address is listed if you have questions or comments. This concludes the Satellite Foundational course on GOES-R for baseline volcanic ash products. Thanks for listening.